Well, we made it. Congratulations, folks. We're almost at the weekend. It's going to be kind of a nice weekend as far as this class is concerned because President's Day is coming up. So we won't meet next Monday. After we finish today's class, we'll be back to it on Wednesday next week. Feels kind of weird. We took Monday off so it didn't overlap with the exam, and we're taking another Monday, but we earned it. We've been working pretty hard. Before we start in our work today, getting into now the Consumer Price Index, any questions or comments to start us out? Okay, my goals when I wake up on Friday and get to work is I'm going to catch up on grading quiz 3. I'm going to go here to the MyLab system and then pull the average grade on all the assignments that have gone past the due dates as we see them on Canvas. And then once I have your grades fully caught up on the 2 homeworks, the quizzes in MyLab, I'll turn over to grading exam 1. I expect to have it fully graded on Friday, but my final cutoff is Sunday evening at the very latest if something goes wrong, if it just takes longer than expected. But my goal is to try to get the grading completed as soon as possible. That way we can have a holiday is my thought. I try not to let the grading ever get into the next week. Echo asks, did you receive the quizzes from the Idaho Falls Testing Center? I believe I have, yes. I've received some from the IF Testing Center. Oh, actually, no, I'm getting that mixed up. Pocatello Testing Center typically uploads their exams to a box folder every evening, so I've received a bunch from those. But the Idaho Falls Testing Center works a little bit differently. The exam was open to be scheduled between Monday through Thursday of this week right here. So what the Idaho Falls Testing Center does is after they've done all the exams for the course, they upload them, they scan them and upload them to an email in one big batch. So I'm expecting to get that probably either tonight, late on Thursday. Let me just double check my email. Hasn't come through just yet, but I'll probably be getting them first thing on Friday morning then. They'll be getting those scanned and sent over to me. It is a kind of nerve-wracking sometimes just wondering if your exam was even received, but they're usually really on the ball when it comes to that. And I'm right here on the campus, so if anything goes wrong, I visit the testing center and see what happened. But I have never had a situation where an exam ever has gone missing. If you were there to take it on the Idaho Falls Testing Center, they absolutely do have it. It just takes them a bit to get it all scanned up and sent over. But other questions at the moment? Okay, well, with where we're at now, we're moving into the consumer price index portion in Unit 3D. Oh, sorry, question first? Or no, that's probably open mic, sorry. So getting into the consumer price index table is a little bit tricky at first, but really what we're doing is pretty much just extending on the work we did on this table right here. This is a gas index table on the gas indexes as they were in 1990. The way we constructed these indexes is we took a value divided by the reference value, and the reference value in the table happened to be the 1990 value. That doesn't really combine very well unless I go like this. So we divide by $1.23 with changing reference values to get all these new indexes. They were just percents. We took off the percent symbol and focused on the number purely as an index number without the percent symbol, and allowed us to do a lot of interesting kind of computations. Like, for example, we could see how much $20 is really valued in 2025 in terms of how much it would cost to fill a tank. The idea was the amount to fill a tank in 2020 dollars, we took the $1990 value, which was $20. We went up to the table and took the indexes. So the 2020 index was 176.4. We divided by the 1990 index, which just happened to be 100, and we got $35.28. But actually, that computation right here is probably the most important idea that we're going to see for most of the problems in these notes. So we didn't have a formula when we did that, but there are formulas here. Let's throw this formula against it. because we're going to use that formula quite a lot just to see how it really went. So here's the formula from later on the table we're going to be using. The idea was the price in Y dollars. That's the amount to fill the gas in the year 2020. So when it says Y dollars, we're referring to 2020 here in this problem. We take the price in X dollars. That was this amount, the amount it took to fill the gas tank in 1990. It was exactly $20. And although this says consumer price index, this works for any index number. We use the index number for the year 2020 right here. So here's the 2020 index number, 176.4. We divide by the index number for 1990. That was the 100 we divided by. And so this is the formula down below that really kind of also justifies how we got to that $35.28. So we'll make these connections stronger as we go into the next problems coming down below. And again, CPI stands for Consumer Price Index, but it's the same kind of idea whether it's a gas price index or whether it's a federal minimum wage kind of table instead. Excuse me. So that's kind of the major refresher so far with what we ended on Wednesday. Any questions on the moment with that computation part C or the formula below? Let me copy those colors just directly so it matches up just as we did it. Okay, well, let's turn to the next big segment of the notes then, the Consumer Price Index table. Like we mentioned, there's lots going on. This is pretty informationally dense. So if there's ever, say, an exam 2 question that relies on this Consumer Price Index table, you pretty much have a guarantee this is going to be reduplicated the last page on exam 2, so we can do those computations nicely. And it's really 6 columns we're looking into by pairs. We have a year, a consumer price index. For middle columns, another year, another consumer price index, and same for the last 2 columns as well. We mentioned we also need to justify what's going on with the 100 value. The value of 100 on an index table is referring to, say, a baseline. This index table for 1990 prices had an index number of 100 because the whole table is based off 1990. If we base these numbers off 1980, we'd have 100 here instead, and all the other numbers would shift based on that new reference value. But this table has not a single 100 anywhere in place, but they're claiming there's an index 100 somewhere. It says this is the average annual consumer price index table. This is the average prices for more than 60,000 different goods across USA. And they're telling us the years 1982 to 1984 are the base of 100 on this index table. There is no 100 there whatsoever, but there's a kind of a small mathematical miracle that occurs on this table. If we take the years in question, 1982 to 1984, we have a consumer price index of 96.5 plus 99.6 plus 103.9. That's exactly 300. So if you divide by 3 to average the consumer price index across these 3 different years, we in fact get the baseline of 100. So we're thinking of this consumer price index table being a baseline value, the average of these 3 years specifically, is where we get that 100 out. That's the trickiest thing about this table. When I first read the book, I was kind of foggy where the 100 was coming into play. But does that make sense to folks on how we get that 100? Okay, and again, this table is really dense. We're thinking of the base years, the reference years, being 1982 to 1984 altogether. And these are index numbers just like the gas index table that we were looking into. So say if we go all the way to 1995, That's an index of 152.4 for the consumer price index. So what that's telling us is that prices generally in 1995 were 1.5 times the prices between 1982 and 1984 as an average. If we say go to 2025, it's saying prices in 2025, recall those are also percents. They are 321.9% of the prices in these base years here, averaged between 1982 and 1984. So lots of information altogether. Any questions at the moment? Just staring at the table, looking into what it's saying. Okay, if we focus on specifically the consumer price index portions, notice how it varies year to year. From 1982 to 1984, that has an average index of 100, so that's our reference values, base years. And then inflation takes over. Prices get more and more expensive generally, and that happens in just about any economy. Deflation is sometimes just as scary as inflation, and we are looking at overall inflationary forces. It's a gradual rise as we go across the decade to 2020 to 2011. It's increasing. And then, suddenly it kind of starts to go a little bit faster in a certain sense, a jump of almost 20% from one year into the next. And we don't have the 2026 value yet. They are going to compute that probably February or March, wherever the federal government gets around to it, of 2027. That's when we'll know the 2026 consumer price index. So this is reported every single month, and any index is just an average for a particular year. So say year 2000, consumer price index was 172%, the cost of goods from 82 to 84 on average. Well, now that we've got that table, this gives us a lot of interesting information. We can ask pretty interesting questions and give very nice answers to it. For example, in the year 1985, across the entire USA, median household income was approximately $23,620. The median is a good statistic. We don't want to say average household income because then all the billionaires are going to skew that average to the higher end, and it's not an accurate reflection of the typical American. The median does a great job of saying, what was the household income for a typical American? Median means the 50th percentile. And then what we mean by that is approximately half Americans, excuse me, let me say that differently. Approximately half of the households in USA in 1985 made less than 23,620 and half made more. So that's what we mean by 50th percentile, or we just say median for short. So 1985 prices, we are wondering if that same household was to maintain a certain standard of living on that income in 1985, that same $23,620, how much would it have to be need to maintain the same standard of living in 2025 dollars? This table is going to help us answer that question. And essentially, we're going to use the formula that we did right here on this part C question to get the answer. Any questions at all, folks, before we delve into the process for this one? Okay, let's bring that handy formula into the page as well so we can see exactly how to track through it with this kind of data in the new index table. So down below, we have a definition for a rate of inflation, but what we're doing is a price adjustment, $1985 into $2025. So here's our handy formula. We'll use this one a lot, so let's screenshot it in here, our first really major use of it, aside from yesterday. So let's take a look into what each of these elements are trying to say. Price in Y dollars, Y is going to be, in this problem, the 2025 dollars. So we're asking what amount is needed in 2025 dollars. We look into price. It could be a price, it could be a cost, or it could be a median household income. The book just had to come up with one word to convey all those possible things. Price in X dollars is referring to the median household income of the $23,620. This is in 1985 money though. So those dollars still, they don't go that far in 2025. So we'll find out how that far that goes, how much that's going to need to be in the 2025 dollars. So I'll say here, amount in 1985 dollars. So that's one big quantity that we multiply it against consumer price indexes. And again, the tie-in with that last problem, example 2 part B, this is exactly the process we took. It was just a different index number. We take the consumer price index for the year in question. That's 2025 in this problem. So we'd go to here on the table, 321.9. But let me write it in as a formula first, CPI, just so we can get some practice with this formula. CPI for 2025, we divide it by the consumer price index for the 1985 year. So CPI 1985. So I really haven't made much progress except take the formula and relate it to the information that we have specifically in example 2. If this state makes a lot of sense and it feels kind of tedious to write every single time, you don't have to write it in. But when you're learning this formula for the very first time, it's a really good idea to pull in the context you're dealing with, write it in down in terms of what this formula would say for your current context. So we'll practice this strategy just to get a feel for exactly how this formula goes. But now that we have it on paper, we're just going to make some substitutions. When we say the amount in 1985 dollars, we're talking about the median household income. So we'll put in here 23,620. So that was a pretty good standard of living, it being the median. But now in 2025 dollars, we have to take consumer price indexes. The consumer price index in 2025 is 321.9. And in 1985, where's that year? Way up here, consumer price index was 107.6. So 107.6. This is finally going to give us a value, the amount needed for that certain standard of living in the 2025 dollars. So here will be in dollars. We'll round this one to the nearest cent. And here's the calculator side of the operation. The end step on this was to take the 23,620, multiply it by a fraction, 321.9, divide by 107.6. And we get this figure, $70,662.43, rounding to the nearest penny. And I forgot the numbers. Let me try again. 70662.43. Guess that's a lot of digits to memorize on a late evening class on Thursday. But that's how much they would need to maintain the same exact standard of living as the median household income in 1985. In terms of 2025 dollars, we need just about triple. But we should expect that because we have just about 300% of these base values from 84. 85 wasn't too different. Well, any questions at all, folks, getting to that dollar figure there? Okay, if you're thinking in terms of unit analysis, sometimes it's hard to get exactly what the numerator and denominator should be. But the CPI in 1985 is just taking something that's in 1985 dollars and causing a cancellation there, leaving the 2025 dollars CPI. That's how we get that end figure. So there's always kind of a nice organization to this. The thing that we're trying to calculate always has the same numerator for the consumer price index. And the thing we started from, the thing we're converting over, it'll always go into the denominator in that same exact way. So if we formulate the question of what we want in terms of what we have, we're just going in order, top to bottom, to format the fraction. This is a very strong pattern that always just carries over each and every time. Well, let's leave this screenshot right here on paper, just so we can see how we use the formula on example 2. Then we'll go off to the next landscape for the more interesting questions. So here's our, oh, that's the next page, the next definition. So we'll put that on the next page. We'll be using this formula, this consumer price index table more and more. But any last questions or comments at all, folks, about the computation or the formula? Okay, like I mentioned, this table is used to describe inflationary forces. In fact, we compute inflation through this table, and that's what the next slew of definitions are all about. The definition here, let's hide example 4, says the rate of inflation from one year to the next is relative change in consumer price index. But that's kind of a welcome term in a certain sense because we have done a lot of work on relative change. Let's see, that's unit 3A. They're talking about this specifically all the way back to the start of the chapter. So if we think in terms of just that old formula for relative change, to calculate inflation, we're not doing anything too different. The major difference is we're just using the CPI numbers, consumer price index. We'll be using this formula more and more. We use it again on example 2. So here's how example 3 goes. What was the overall rate in prices due to inflation as a percent from year 2005 to 2025? And we're making the assumption that prices for just about everything have risen at the same rate as the consumer price index. That isn't always exactly true. It depends on what commodity, what thing we're looking into buying. For example, housing has just exploded in Idaho Falls, not keeping up with CPI, and other things are just right in line with it. So depends on exactly what quantity or what product we're mentioning. But for an overall average, this will give us a good feel for how bad was inflation from 2005 to 20 years later, 2025. We focus on the fact that we're just doing nothing other than relative change. So let's make that idea really compact by just dropping this formula in. So here's our big tie-in. All the way back from unit 3A. Well, what do we need next? We're looking at the overall increases in prices due to inflation as a percentage from year 2005. That's going to be the reference value. Usually the reference value is a historical figure. So we're going from back in the past to not quite the present, but we don't have the 2026 values. So this is what we're going to regard as our new value altogether. But we're using CPI to make these adjustments, so we also need to cite that table. Let's first just say, to start out, relative change. Or rather, let me backtrack a little bit. Recall what we're actually calculating is the rate of inflation from those 2 years. So let's say it that way to make it more concrete. The rate of inflation it happens to be a relative change. That's where I kind of got mixed up on my start right here. Because it's a relative change, we can say it's the new value. What's the new value? It's going to be the CPI, Consumer Price Index, in 2025. The reference value is going to be the Consumer Price Index in 2005. So those are the values that we're plugging in. CPI 2025 did not make that fraction long enough. Let's extend that. Minus consumer price index 2005 divide by consumer price index 2005. Notice the pattern always kind of goes the same for relative change. Reference value is your denominator. Then we want a percent. We're going to express this as a percentage, so go times 100%. Not an index number this time, so we'll keep the percent symbol for this problem. Now we just need to do that table lookup for those two consumer price indexes. So let's put this on paper next. If you have your notes pulled up or printed out, maybe on a separate screen or something like that, that'll be pretty handy for any one of those tables. Here, I'll just use this strategy. I have consumer price index on one of these tabs. Here it is. Okay, let me blow that up a little bit more. I want the consumer price index for, let's see, 2025 to start. So we'll pull in the 321.9 and put it on paper. Minus consumer price index for 2005. Oh, wrong tab here, 2005. So that's the column in the middle, all the way down right here. Again, there's so much information here, it's good to go kind of slow. And it's a good idea to familiarize yourself with this table, since I'll be printing this table in exactly that format and shading and bold and all as the last page on our exam 2. Consumer price index in 2005, 195.3. So let's drop that in. Once we have that term, we just drop it into the denominator as well, 195.3. It's nice to see how consistent these formulas really are. Go times 100%, and now we have the rate of inflation. We look at the table. In 2005, consumer price index was 195.3. In 2025, it was 321.9. So I'm expecting a pretty big figure on this. It jumped a lot, but we're talking about the rate of inflation with this as the reference value. So our percent is a percent increase from the 2005 CPI. So in the calculator, let's go with the fraction 321.9 minus 195.3, 195.3 again, times 100. And this one's a percent, so I'll round this one to 1 decimal point, 64.8%. So the rate of inflation from 2005 to 2025, 20 years later, was staggering 64.8% inflation. That's in just 2 decades. And it really started seeming like the CPI numbers were accelerating in their growth amongst those years. So you probably wouldn't see the same value if you went from, say, 1985 to 2005. It's going to be a lot, but I bet you not as much as this one. This was a pretty big figure. So again, the federal government in USA uses that CPI table to measure inflation on a year by year, month by month basis. And this is the same kind of computation that they might do. Any questions at all, folks, with the example 3? Okay, I didn't ask a lot of inflation kind of problems like this one in the actual MyLab homework, but there is one. So when you see that one come up, it's tricky because it's going back to the relative change formula. This would be a good example to revisit just to refresh how the computations go. A lot of the problems in the notes are really just going to be based off of this right here. Like, let me pull the screenshot with the color coding already set up because I want to keep that color coding as we go from problem to problem. So here's another additional question relative to the consumer price index. And a lot of these problems feel kind of practical. They are kind of the kind of questions you might think of yourself on a daily basis, perhaps. Kind of questions that could come up if you're buying a car. It says here, assume that a used car that you could reliably, that could get you reliably, sorry, from home to work every day. So maybe it's kind of a beater car, but it gets you from point A to point B without any trouble. A car like that in 1995 would cost about $7,000. And for a typical example, a 5-year-old Honda Accord had that approximate value in 1995. So if you were buying yourself a car that's just going to get you to work, $7,000 was not the exact value you would have spent, but a pretty reasonable middle figure, kind of like a median income in a prior problem. So we're wondering if it costs you $7,000 to get behind the wheels and get to work in 1995, how much would that same cost be in 2025 dollars? Really, we're just using this formula down below. We're adjusting prices for inflation through the CPI table. And we're going to make a big assumption that might not always be true for every sector of the economy, but we're going to assume as far as used car prices go, that they're keeping up with the consumer price index table, that's a pretty good approximation. Okay, that's the statement of the problem so far. So what we have to determine is what's going to be considered this part, the price in Y dollars. Usually that's going to be the more recent data, the part where it comes from the question. So the question is the part you would put right here. How much would this car cost in 2025 dollars? So let's write this out in words just so that we can take all this context and fit it into the formula accurately. Cost of this car in 2025 dollars will be equal to, we need the price in X dollars. Well, what's X dollars? That's the historical figure, the 7,000 in 1995. So let's plug that in. Let me scroll down just a bit. So 7,000 in 1995 dollars is going to be multiplied by these indexes. So I'll put here cost of the car in 1985 dollars. That whole thing gets multiplied by these indexes. So we'll put in the same exact format. If the thing came first was a cost in 2025 dollars, that's going to be the numerator, CPI in 2025. If the thing came next was in 1985 dollars, that forms your denominator, CPI in 1985. And if we got this backwards, it's an easy fix, because if we got this backwards, it would have been less than $7,000, and we know something is wrong. Costs have only gone up since 1995. So if you get a number that's too small, just flip this fraction. That's probably the problem, and you're more likely than not getting the right figure. So let's put in this spot right here, the $7,000. Now we're looking up the indexes. CPI in 2025 comes up only because that's our most recent data. And wrong tab. CPI, oh dear, wrong tab again, wrong button that rather. The CPI in 2025, we're putting in this numerator. So that'll be the 321.9. Then divide by this consumer price index in 1985. So back to this. 1985, we're almost to the base years, 82 through 84 in this table. So that's a small 107.6 for that index. And this is going to do the price adjustment, adjusting for inflation through the CPI table. So we just about have a value. Any questions at the moment on getting to this part right here? I think this is the trickiest part of the whole problem, seeing how the numbers land, working it through this formula.
Yeah, you used the wrong CPI it should be for 1995, not 1985.
Oh, thanks for spotting that. So yeah, and I miscopied that several times. Let me put here, these numbers are going to come out really weird. 1995 here. Let's make an adjustment on that spot. And I have too many tabs open. So 1995 is here, 152.4. Yeah, that's going to make a humongous difference, actually. That's a big change. 152.4. And that'll get us on the right track. Thanks for spotting that error there. Other questions or comments so far? Okay, we just about to have a dollar amount. Notice this number in the denominator goes into the numerator about twice. So it looks like it's going to be about double altogether. Let's get the exact figure. 7,000 times the fraction, 321.9 over 152.4. To the nearest cent, we're going to spend $14,785.43. And again, that's too many numbers to memorize in an evening class on a Thursday, so let me double check. Okay, now we might wonder, is that accurate? Does it really cost about $15,000 for a beater car getting you point A to point B in 2025? I think that's kind of debatable. I haven't been looking at used cars prices recently, but I do remember in some years, used car prices did kind of blow up for a little while in this area. But the consumer price index table isn't trying to give us full on accuracy. We're not saying that's an exact value. It just gives us a ballpark, where to start. If we want to get a better approximation, we have to look closer at the specific sector of the economy, not overall CPI, but maybe just used car prices themselves, maybe in an area like Idaho or even say Idaho Falls to get a better figure. But the consumer price index, once again, it's just a great starting point. It's an average of 60,000. Here we go. 60,000 different products, services, goods, housing costs, renting costs, and everything all rolled into one. So even though that number isn't fully accurate, if it seems a little bit low or maybe a little bit high, it's our baseline for just making our first estimate. Well, that's one computation down. We'll do several more along these lines as we go through these notes with the CPI table. Then we'll turn to the federal minimum wage table for related kind of computations. But this entire analysis, how we put these numbers down on paper, they're going to convey over even into the next table for federal minimum wage. Well, here's our next scenario to take a look into. This one's buying laptops. Seems like a lot of this is just ordinary life kind of stuff. Getting to work or school, buying a car, buying equipment for school, say like a laptop. You can spend a remarkably low amount of money on a laptop that will do the job for you in school. I'm not sure how much that might be, but I bet you could spend $700 and get something that just works. But if you're getting, say, like an Apple product, maybe an iPad Pro, something like that, that could be really expensive, depending on how you load it out. So I went with something that's kind of in the middle of the road. We're going to assume that the cost of I'd say slightly higher end, typical student laptop or tablet PC, let's say it was $1,400 in 2025. And you can get something absolutely that works for $1,400, especially if you're getting something used. Maybe certified refurbished is kind of risky, but that could work out. But for something brand new, that probably should get the job done for all years of school. But we wonder now, if you could buy laptops in 1985, just making it kind of a hypothetical assumption, what is the cost of $1,400 in 1985? Notice how weird this question is, though. Computers in 1985 were extremely expensive, and laptops didn't look like what they look like now, if any existed at all. I bet you there were some niche products. So if you took a laptop computer from 2025, the same computer, and showed it to someone in the federal government in 1985, you'd probably be abducted, and the FBI is going to have lots of questions for you because that's going to look like alien technology. You'd probably be the closest thing to a real alien the federal government has ever come into contact with. So we're not talking about the same laptop in 1985. We're not really even talking about buying computer technology in 1985. We're mostly just wondering, how far does $1,400 go in 1985? What's the equivalent amount? It's going to be less because the consumer price index compared to 2025 has fallen if we're going backwards in time. So again, if we're thinking of this problem very literally, it's kind of a silly question in a certain sense. We're imagining we're buying some kind of computer system in 1985, not the same one that you would get you're possibly using today. And the other assumption is, well, computer technology probably has not kept up with CPI whatsoever. Computer technology has gotten remarkably cheaper over the years as it's become easier and easier to build chips. But if we take this problem at face value, here's how we're going to do the computation. I think the related problem is something like buying a box of cereal or something like that, which is a little bit more reasonable than this problem, but this is still a fun one to get through. What we need is to adjust price for inflation, but notice what's changed this time. The question is about the price in 1985 dollars. So that's what goes here, the thing in green. So the thing we're adjusting is always this part right here. So we'll start by writing out price of the laptop in 1985 dollars. So that's how we're going to start. We're going to take the price of that, say laptop in 2025 dollars, and that's where this figure comes into play. So this will be multiplied by the price of the laptop in 2025 dollars. It is kind of tedious just to pen in these two sentences in this verbal equation that we're writing out. But if you can get these two things identified, even if you're pointing arrows, it tells us exactly what this fraction is going to look like. The structure is always the same each and every time. The thing that came first, which came from the question of the problem, is the numerator, CPI 1985. Then we have this value. This is going to form the denominator, CPI 2025. And now with this entire structure here, all we're doing is dropping in numbers just like before and running the calculator through it. So let's drop these in. The laptop in 2025 dollars is $1,400. Now we're going backwards in time. We're going to rewrite this $1,400 in 1985 dollars. So back to this table. Let me be careful. Let me know if I grab the wrong value again. So much stuff here. It's easy to kind of just get visually overwhelmed by it. But we're looking into 1985. So we'll use the 107.6 figure for the numerator. Then back to that table. The denominators for 2025, 321.9. And that's pretty much the same structure. From example one, I believe it was part C, we did exactly the same formula. We just didn't have this formula to reference just yet. But it's kind of nice to know a lot of these questions go exactly the same kind of way. The trick is just to decide what is the quantity that goes here and what's the quantity that goes here. So any questions at all, folks, with the numbers on paper here? Okay, putting it into the calculator finally, we're going to get $1,400 times. Now we're using a price adjustment for inflation, but now we are time traveling backwards in time, 321.9. And if you could get some kind of computer system, maybe it's a laptop but it's going to look pretty weird. The equivalent $1,400 in 2025 becomes $467.97 in the year 1985. Forgot the cents, and 97 cents. But again, sometimes these figures feel reasonable. Say maybe this was a little bit more reasonable figure for the beater car in 2025, spending that amount of money. But this one is a kind of a strange one because once again, not every single product, not every single sector of the economy keeps up closely with this table. Lots of things do, but this is one of those things where actually buying a decently powerful laptop computer in 1985, if you could even find a laptop at all, this is probably going to cost you, I don't know, $5,000, $10,000. Computers were very expensive in 1985 dollars. Well, any questions at all, though, folks? Just running through the computation. Okay, I believe at this point, this takes us to the next segment of the notes. We looked a lot at consumer price indexes, and there's equivalent problems you'll see as well in the MyLab exercises. And I believe as far as the quiz number 4 goes, let's take a peek at that. I believe this is going to be a consumer price index table kind of question as well. Well, definitely the table's there, so that's a good sign. This one is a pretty strong carryover from a problem that we did do. We're looking at median household income in year 2000. This is all of USA as a median value, being 42,148. We want to know how much would that be in 2023 to maintain same standard of living as it was in 2020. Take a look at the notes to see just how that computation has to be put together. Pretty much it's this formula here. You just have to decide what's the part in green, what's the part in blue, and run the numbers through. But the good news about inflationary forces is you're expecting more for the same level of income. So if you get a value that's small, probably you just have to flip this fraction to get the right value. But next, we're changing gears to the federal minimum wage table. This is a table that I took out of the textbook and just reformatted it to look like the other tables we have. This says it's the federal minimum wage for years in which a change occurred. So there's a change from 1938 to 1939. Then we skip years to 1945 because it went up 10 cents. Feels generous, I guess. But I have to admit, I changed this table a little bit because I want to extend out to 2025. So there's no change in these years whatsoever, but I felt like I wanted this information in the table. So just to be extremely precise what this table is, it's minimum wage for years which a change occurred, except for years, let's see, there's a change from 2008 to 2009, but no change 2020 to 2025. I just duplicated those values just to have the interesting figures here. But there's more going on with this table. It's not just about the federal minimum wage. We have actual dollars versus inflation adjusted 2020 dollars. How are these calculated? Well, the federal government has a plethora of tools, but the consumer price index table could be used as well to calculate these values. So we'll loop back to this table and some of the questions down below here. But some of these questions aren't really just about the index numbers. They're just about the dollars and the inflation adjusted dollars. So even though 25 cents was the minimum wage in 1938, that represented a $4.59 minimum wage in the year 2020. Still not great because the actual 2020 minimum wage was $7.25, but it's not as harsh as it might seem. Inflation just makes these look kind of crazy low. So everything is centered at a base value of $2020. And notice how this column changes. It grows pretty fast. 1968 in particular was a phenomenal year. But then something happened between 1968, somewhere around 1970, something happened to the economy. It starts actually going down. In terms of 2020 dollars, in 1990, the federal minimum wage of 350, that's about $7. That wasn't as great as it was for a 160. That was worth about almost $12 in 2020 money. That's nearly a $5 difference. That's kind of impressive in a way. So something happened to the economy around 1970-ish, and these numbers started falling. Not always. There's a nice bump out here. In 1991, it reached $8, fell, got bumped up again. It fell and it got bumped up again, but we're never getting back to the almost $12 in minimum wage in 1968. And it's just been falling ever since. So here's where we're at now, $5.83 for minimum wage. That's about like, let's see, one of these years, way back in the day, practically 100 years ago, not quite, but almost on that order of magnitude. It's not very impressive in 2025. So the actual 2025 dollars is $7.25. But adjust that backwards in time for inflation, like we did on our very last problem with the laptop, and we realize 725 is just not the same. It doesn't have the same purchasing power. So this table isn't all about minimum wage. It also allows us to ask pretty interesting questions. Along the lines of example 6, how much is $1 in 1945 dollars worth in 2020? Before we address that, any questions about the table itself? Okay, again, these are pretty tough tables because it's extremely informationally dense, kind of like the CPI table. There's lots going on. But now, if we're answering a question like this one, the good news is we're not doing anything too different. Sure, we're not using CPI anymore because we're using the federal minimum wage table, but the logic of how this formula comes together is exactly the same. So even though I'm not using consumer price index, I'm going to still think in these kind of terms. We look to where is the question? How much is a dollar worth in 2020 dollars? That's going to be the part that goes right here. So we'll say $1 in 1945 in 2020 dollars. So that's our baseline. And notice the question is not exactly answered on this table, but we do know in 1945, 40 cents is equivalent to $5.76. It just happened to be that's also the minimum wage. If this was a dollar and I had the number here, our work would be done. We would just copy that in. So the fact that it's 40 cents, that's what's going to make this work a little bit different for us. But that 40 cents right here, well, actually, let's start with this. This dollar right here is what's going to go in that portion right there. And that 40 cents we see here for 1945, it's what's going on in the denominator. So let's complete just the verbal equation, then dump in the numbers. The hardest thing about this is just to say, how do the numbers come together? So we'll start by saying $1 in 1945 dollars. We're going to multiply that by no longer consumer price index, but following the color coding, we know 40 cents is equivalent to $5.76 in 2020 dollars. Same exact organization as just about every problem we've done. We take this, we drop in a different number, not consumer price index, but dollars in 2025. I'll say money, so I don't say dollars twice. Divide that by the number of dollars. in 1945 money. And once again, unit analysis is kind of helpful here. When we say in 1945 dollars or in 1945 money, that means we're doing a kind of cancellation. What we're going to get is $1 multiplied by some figure, but the unit will be in 2025 dollars or 2025 money. Or another way to think about it is we're just working this formula directly once again. If we get something strange, like $1 is worth, say, 12 cents in 2020 dollars, the mistake was probably we need to flip that fraction as most likely than not the major culprit. But here's now the numbers just being dropped in. Take $1, $1 in 1945, multiply that by using not the CPI table, but this time we're using the inflation table here for minimum wage. We'll put in 576. Because $5.76 is equivalent to 40 cents in the 1945 money. And that will get us where we need to be. So if you know anyone who was born in 1945, you can now tell them how much $1 was worth in 2020, and you can do a different computation to bring that to 2025 if you wanted. So another computation, but pretty much the same exact structure. A number times a fraction, 576 divided by 0.40 this time, gives us $14.40 altogether. Well, we did it. Well, essentially, all this is saying is, if you time travel back to 1945 and you happen to have $1, based off the table above, you would know that the purchasing power is about $14.40 if you time traveled from the year 2020 in particular. Well, that's kind of a cool computation, and we can address a lot of interesting things through this table. But any questions at all, folks, getting through this one? Okay, well, let's delve into the next questions. I have a couple more questions on the notes to get through, but we're not going to try to race through the very last one. We'll just see where we end up at the end of example 7. Again, this is a good section to have just your notes pulled up or printed out or on a different screen for. We need the consumer price index table, and we also need the federal minimum wage table as well for our next computations. So let me get these kind of all in line. Example 7 comes in 2 parts, and it starts by saying, use the average annual consumer price index table to convert the 1990 minimum wage from the actual dollars, so they're saying the actual dollars of $3.50, to the 2020 dollars. And you know, that feels like a really weird question. You might feel weird when you see this one in my lab, because if you're looking at the federal minimum wage table, and you need to be to do this question, you're probably expecting the answer should be $6.94. That's what part B is all about. If we instead use the consumer price index table, will our result be consistent with what the federal minimum wage table is already telling us? That a minimum wage in 1990 is $6.94 in terms of 2020 dollars. So that's the logic of how the problem is going to go so far. And really, we're just using this formula once again to get through it. It's tricky because, again, we're also using a bunch of pretty technical looking dense, informationally dense tables at the same exact time. So let's think of this really carefully once again. Use average consumer price index table to convert 1990 from actual dollars to 2020 dollars. There's no question here, but we could imply a question. What is the 1999 minimum wage in terms of 2020 dollars with a question mark? And that tells us that's going to be the value that we would write in here. The thing that we're trying to compute, or the thing that's the question of the problem, is always what goes right there on the red dot in our big formula. So we'll say 1990 minimum wage in 2020 dollars. So following the color coding, that's the left-hand side, will be equal to, well, now we have to find the 1990 minimum wage. So that's our next stop. We need to be in the federal minimum wage table, but let's write this out in words first. So we'll go the 1990 minimum wage in actual dollars. When we say actual dollars, we just mean not inflation adjusted whatsoever. We'll take that and multiply. It told us to use the consumer price index table, so now we're really using this format. Then once we have these two things in context with the dates, this one being the particular one, we can now rewrite this as CPI 2020 divided by CPI 1990. And go from there. So again, it's a lot of work to start out, but in terms of just seeing how this formula goes, it's a worthy step to take the time to write that in. Then at this stage, we need to go to the federal minimum wage table. We need to know the 1990 minimum wage in actual dollars. So in actual dollars, $3.50. So let's pen that in. $3.50 goes here. Now we multiply. New table, we're using the consumer price index only because they told us to do so. So back to consumer price index, we're taking the 2020 value. So that's over here, 258.8. That forms the numerator. Then divide that by consumer price index in 1990, 130.7. And we're just about on our way. So once we do this computation, we have converted the 1990 minimum wage into 2020 dollars. We've inflation adjusted it. But notice how our computations in the Desmos calculator, it's almost been that same exact structure for just about every single problem, except for the rate of inflation problem. So take 3.50 times 258.8 over 130.7, and we get, this is in terms of minimum wage, $6.93. And we want to put it in that unit exactly. Keep in mind that this table right here is a minimum wage. So this is really 25 cents per hour or $3.50 per hour. So no harm done being a little more specific and say per hour. So if we use the inflation adjusted prices formula and all we use is the consumer price index table as our major tool, we've adjusted the federal minimum wage of $3.50 to $6.93 in 2020 dollars. So our work is done on part A. Any questions at all, folks, with that computation? Okay, and part B, this is one of those questions in my lab where you just select a tab that says yes or no because, and they give you a response, this or that. So it's kind of like a multiple choice kind of question. If this was a real exam question, it's going to be kind of a hard one to grade because it's pretty subjective. If you are thinking in terms of exactly what you see on the federal minimum wage table, you're being asked the question, is $6.93 in 2020 dollars consistent with that table? Some might say no, because it's $6.94. Some might say yes, because we're off by 1 cent. So again, it's kind of open-ended, but if you tell me why you made your decision, you'd get full credit on this kind of question if it ever came back as, say, an exam 2 question. Just justify why you made your decision. That's the explain part right here, and you'd be just fine. But for me personally, if we got a figure of 693 and federal minimum wage table says 694, I would say yes, that is consistent because we're using tables that have rounded values to one decimal place. When the federal government did this computation, they probably used a lot more precision in their actual numbers when they came up with that figure there. So just due to effects of rounding, we're off by 1 cent, and that's enough to say we're within a reasonable margin of error. So me personally, I would say yes, this is consistent because the difference of 1 cent, 1% of a dollar is likely only due to rounding in the CPI table. Index numbers are rounded to 1 decimal point, but we're trying to get something down to the nearest penny. We do need more accuracy in that table. So that discrepancy is not a big deal. This is a very consistent number with the federal minimum wage table. In fact, when they inflation adjusted this, keep in mind, the federal government computes rates of inflation through that table. So we should expect it should be a consistent figure. If we use a CPI table, or if we just looked up the federal minimum wage, we're getting pretty close numbers. Well, any last questions, folks, on getting through this one?
A question if on the consistent part, what would you where would it switch for you to not be consistent? Like what kind of range would you say?
Oh, so for not consistent, I would say anything like 10 cents or more. It's starting to look pretty off to me. So being within a nearest 1 or 3 cents, that could be explained to rounding. But if we got an answer that was, say, like $7.03, that's significantly different, in my opinion. So we could say in terms of percents, anything that's, say, about 10% off of this is probably a concern. That would be roughly about, if that's $7, around 7 cents, or 10 cents would be a good figure.
Okay,
Does that make
thank you.
sense with that question there?
Yes.
Awesome. And again, it's a pretty weird question because if we're going right off the CPI table, pretty much we're always going to be right to the nearest penny, maybe off by 1, potentially 2 at the worst. But if the problem context changes weirdly enough, we're off by, say, around 10 cents or more, that's when I would say no for sure. Well, we got to about the end of the time. I didn't get to the last question. How high would the minimum wage need to be in 2025 if we took the 1956 value and adjusted, inflation adjusted it, not to the 2020 dollars, but to the 2025 dollars? That'll be our last question for these notes here. So since I didn't quite get through this one, I am going to push the due date on this one so that it'll be due at WebAssign when we come back, finalize it on the 18th for a due date of the 25th. But thanks for your hard work on this, folks. I think that when I was doing the lecture notes for this and the reading for this, this was pretty confusing to me, getting these values just right. So if you're finding this section to be tricky, don't hesitate to reach out. You could bring up one to start off on class when we come back on Wednesday, but use these notes as a guide and the formula here as the major organizing tool, and it won't be too bad to get through. But have a great weekend, folks. Have an awesome holiday. We'll be back to this on Wednesday's class. Take care.